We'll continue with MGF. Now let's go to normal distribution. It follows normal distribution. MXT will be equal to, maybe last time I used K in the class, K mu. But here it will be T because we are using T. Yeah, formula only I must have last time said,
Yeah.
right?
Yeah,
Okay.
formula.
So what is differentiation? Double differentiate. We can do this way. This, then differentiation of this will give the same thing once again, right? About the differentiation of the first one, keeping the second constant. Procedure, right? Now, we can make our life easier. We have another function called cumulating generating function, cumulants. The definition for this is log mxt. And if you take log, directly you will get Ex variance of x. Ex will be this 0 and here double. Now, this is called cumulant. So what will happen is you just take log. And we can prove this one. Will not worry now. So what is Cx? Log mxt, right? What is mxt? E t mu. What will be Cx? Do you think it will be Tm t mu plus half sigma square t square? Log E, they will get cancelled, right? Log and E, they will get cancelled. Log and E, you should get A. So there is no more E now. Now differentiate. Which one is easy? See, I have done it. We directly get mean and variance. So when Cx will be better, if you have E power, in the moment generating function, if you have E power, and you are taking another log and E, they will get cancelled. That's why you will get a simpler expression. Cxt will give you the mean and variance directly. So this is the first practice question. This is exam question. So one way is to take differentiation, right? Double differentiation.
Yeah.
Do you like to use CXT here or MXT is fine? Do you know any distribution whom you can match? That way, you know, your calculation will be faster. Instead of differentiating 2 times, putting 0, that way you will get anyway. But yeah, it takes some time. Because time is an important factor. If immediately you are able to compare with some distribution, then that would be great. Which distribution? Q plus pt power n, right? So this should be binomial. Is 9 and p is. Now let's go to the next problem. Here mxt given, and actually determines that the claim size for a certain class of academics accidents is a random variable. With MGF given, you need to find the standard deviation. If you know the variance, you can take square root. You will get the standard deviation. Exponential. Okay, let me write it that way. 1 divided by, we have power 4 also. You find gamma, it was lambda divided lambda minus t. Okay, if you take lambda common, then you will get 1 minus t divided by lambda. So lambda you can cancel. And you get 1 upon 1 minus t divided by lambda this way. 1 minus 1 divided by 2500. This is your lambda into t. I have not written the power. See, this is gamma. Okay, remember. If x follows gamma alpha lambda, and mxt is this. We compared Bernoulli with binomial. Similarly, taking exponential, you will get gamma. Even this is not required. You can compare with this one directly. If it's not exponential, because you have a power, we'll directly compare with this one. You compare these two, okay? So now what is alpha? Alpha is 4 here. And what is lambda? 1 upon 2500. Correct?
Okay, fine.
If I give mxt, then can you find ex and variance of x? What is lambda here? What is lambda here? That is what you have to say. I means you can write this way, right? This way. Here alpha will be 5. Normally in questions they will try to trick you. If you get this way, then square root. Let me write it properly. This
Can
one,
I do-
suppose I will write 1 minus 2t square root. That will be 1 2t half. Then 1 divided by, you have to write. It will be this way. Then you have to write. See, you have to write in this way. It will not work because this should be an integer, right? For lambda, any parameters, right? See, you are able to write that way or not. Remember, if a particular way is given, you try to write that way. That's all. Yeah, there is no constraint. Okay.